Okay, this lesson is on compound interest, and we're going to go through the PowerPoint and then work in the lab manual on pages 45 and 46. So your learning objectives here are, the compound interest formula is for money. Given a savings account scenario, we're going to use the APR, the compounding period, and the initial principal to determine the compound interest model. Then we're going to use the model to calculate how much money will be in the bank at a future point, and also use the model to solve for the length of time needed to reach a given level. Okay, so the compound interest formula is B of t equals P times 1 plus R over N to the NT. And I'm going to go through what each of these variables mean. A B of t, that's just your Y equals, that's your output. But P is the initial money amount. And R is the interest rate. And it will be given as a percentage, so you need to make sure that you remember to convert the percentage to a working value. That's what we've been calling it. So we're going to convert it to a decimal by dividing by 100. So if you're given an interest rate of 7%, 7 divided by 100 would be 0.07, and 0.07 would be what would go in the formula. And then N is the number of times the money is compounded. And we'll have different examples to explain what that means. Compounded per year. So if I say the money is compounded quarterly, then that means it would be compounded 4 times a year, and so N would be 4. Now your T is always your time in years. It's always in years. Okay? And one other note before we move on is that when you put this formula in the calculator, please make sure you remember to, if you have an old operating system, to put parentheses around your NT, because if you don't, you'll get it wrong. You'll raise it to the N power, get an answer, and then multiply by T. Well, we don't want that. We want to raise it to the N times T power, so you will need parentheses there. Okay, so this first example, annual compounding. So I've written the formula that you'll need to memorize. B of t equals P times 1 plus R over N to the NT, and we're going to plug in what we are given. You invest $1,000 at 5.5% compounded annually. Write the function of B, the balance of the investment, in terms of the T, years the money has been invested. Okay, so you have B of t, and your P stands for your initial money amount, so that would be 1,000. And then the formula has 1 plus R, and R is your interest rate, which is given to you as a percent. So R, 5.5 divided by 100 is 0.055. That's your working value. That's what goes into the formula. Okay, now your N, it says compounded annually. So that means your N is only going to be 1. And it's to the NT, so that would be 1 times T, so I'm just going to write T there. So if we clean that up, we would end up with B of T equals 1,000 times 1.055 to the T. And that ends up going down to A times B to the X form, which we should be familiar with. Okay, so the first question says, what is the balance in the account after 10 years? So this is an input-output question. So we're going to, if we use function notation, we're going to have B of t. That's just going to say that we're going to find the balance after 10 years is equal to 1,000 times 1.055 to the t. And if we put that in the calculator just like we've written it down, we should get $1,708.14. Okay, so question 2 says, how long will it take for the account balance to reach $1,500? Okay, so this is where we know the ending balance, and we want to know what T is. So this is an output-input question. So I'm going to need to put 1,500 in for B and write a new equation. And I'm not going to be able to solve for T unless I use my calculator. Okay, so before we do that, I'm going to show you a little trick so that we don't have these huge windows in our calculator to work with. We can actually divide out a portion of this to make the values stronger. And since this is multiplication right here, I can divide both sides by 1,000. These thousands cancel out, and 1,500 divided by 1,000 is 1.5. And so you're left with a much smaller equation to put in the calculator. And so that's what I'm going to start doing every time. You can do that every single time. You can always divide out the initial value. Okay, so we know that T is equal to 7.57 years. That's how long it's going to take your balance to reach a balance of 1,500. Okay, so what I'll do is I'll put the equation in. I like to put the exponential in first. Hit enter. And the left side of the equation is 1.5. So this is going to be an exponential. It's going to be a backwards J, and this equation is going to give me a horizontal line. And because the numbers are so small, if I hit zoom 6, I'll immediately be able to see it. Here comes my exponential, backwards J. It's increasing slowly. Here comes my horizontal line, and I'm not quite sure that the intersection is here. It probably is, but let's go to the window and let's increase our years just a little bit. And you can go as high as 50 if you count by fives. Then it's still going to look good. Here comes our exponential function. It's increasing. Here comes 1.5, and I can clearly see the intersection. So now I'll hit second calc 5. First curve, hit enter. Second curve, hit enter. You don't need to guess, so hit enter. And the intersection is 7.57 years. Okay, so this next exercise has to do with quarterly compounding. And so it says $5,000 is deposited in an account at 4% APR, compounded quarterly. A, write the function of B, the balance of the investment in terms of the T, years the money has been invested. B, what's the balance in the account after 3 years? And C, how long will it take for the balance to reach 10,000? So the formula that we'll use, B of T is equal to P times 1 plus R over N to the NT. And when you have quarterly compounding, what that means is that N is 4. 4 times during the year, we're going to compound that interest. Okay, so if we plug in all the things that we're given, we have B of T is equal to 5,000 times 1 plus 4%, which is 0.04. That's our working R. Never put the percent in. Got to put the decimal in. And then we just said N is 4 to the 4T. Okay, and so we can clean that up if we go ahead and put 1 plus 0.04 divided by 4 in the calculator. And that gives you 1.01 to the 4T. Okay, so that is the answer to question A. Question B says, what is the balance in the account after 3 years? This is an input-output question. So if we put 3 in for T, then we can use the calculator to evaluate. Now remember, you need to use parentheses. Okay? Okay, so we can see we get a balance of $5,634.13 if we round it to the cent. Okay, so the next problem, how long will it take for the balance to reach $10,000? So this would be an output-input question. And we'll have to plug 10,000 in equals 5,000 times 1.01 to the 4t. So this time the t is what we're looking for. And remember last time we said we can make these numbers smaller by always dividing out the 5,000, or the initial value. So that's going to give us 2 equals 1.01 to the 4t. And so we'll need to use the crossing graphs method to solve this equation. Okay, so when you solve this, you get 17.42 years. Let's move on. Okay, so if I put in 1.01 to the parentheses for x, and I realize with this operating system I wouldn't need those parentheses, but I just want to make sure that people that don't have the operating system that raises the power remember to use parentheses, because if you don't, you get it wrong. So the second left-hand side is y equals 2, and because these values are so small, I'll just hit zoom 6. Here comes my exponential function. And here comes my horizontal line, and just don't think we have enough intersection for this one, so I'll make this 50 again, count by 5s, watch it again. Clearly we have an intersection, so we'll hit second calc 5, enter, 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 and the answer here, 17.42 years. Okay, so this example has to do with monthly compounding. So again, I like to write these formulas out over and over again so that I can memorize them that way. So that's the formula you're using. It says Callie received a $1,500 bonus. She chose to deposit her money in a savings account earning 2.95% compounded monthly. So in this case, there are 12 months in a year, so your N is going to be 12. It says A, write the function of B, the balance of the investment in terms of the T years that you've invested. So B of T is going to equal 1,500, that's your initial money amount, times 1 plus 2.975 divided by 100 is 0.02975. Compounded monthly, so N is 12 to the 12t power. Okay, so what I like to do, it's not necessary in terms of when you're calculating. Your calculator will kind of simplify this on its own, but I like to see a simplified version, so I'm going to put 1 plus 0.0975 divided by 12 in the calculator. And get 1.0025 to the 12t. Now that is got potential for a rounding error, so you may not want to do that. For writing it down as the answer to A, it looks a little cleaner, but you may want to consider using the unsimplified version when you're calculating, and that gives you less rounding error. So I'll use that one to answer question B. What is the value of her bonus, which is her bonus plus all interest after 5 years? Okay, so you can see that it does make a difference when you round. So we're going to take the exact answer of $1,740.25 as our answer. So then question C, which is right here, says how much interest has she earned over the 5 years? So what this question is asking you to do, if her bonus was $1,500 and she put it in the bank and now she has $17.40.25, how much interest has she earned? So that's just as simple as subtracting 1740.25 minus 1,500. And simplifying that would give you $240.25. Okay, so if I type this whole thing in without any simplification, I'll just have 1,500 times 1 plus 0.02975 divided by 12 raised to the 12, parentheses 12 times 5, close parentheses, and then hit enter. If I do the rounded version, I'm just curious to see what the difference is. And you get quite the bit of difference. You get a $2.43 difference. So that's a great argument to use the unsimplified version when you're evaluating, so that you get a more exact answer. Okay, so now this is going to be a change. We want to find the initial balance. It says determine the amount Dean should deposit now so that he has $28,560 in 5 years if the savings account earns 3.1% APR compounded monthly. So again, if we write down the formula, B of T is the ending balance, P is the beginning or initial balance, 1 plus R over N to the NT. So here, this time, we are looking for P, and we're given our ending balance. So if I substitute 28,560 in the ending balance, P is going to be my unknown, 1 plus R, which is 3.1 divided by 100, so that's 0.031, over its compounded monthly, so that would be 12, to the 12, and we want to know how much he should invest initially if after 5 years he wants 28,560. So this is going to be 12 times 5 right here. So our only unknown is P. So what we need to do is we need to remember that if we multiply and simplify all this out, we're going to end up having to round. But I still want to do that first. But what I want to try to show you how to do is to use your calculator answer function to sort of capture that approximated value. So before I do that, I want to go ahead and simplify it on my paper so I have no problems with the algebra. So I have 28,560 equals P, and I'm going to go ahead and put this in the calculator. And get a value of 1.1674, and it keeps going. But I'm going to go ahead and write that down so we can think about what we're going to do next, and then I'll show you the video of how to use the calculator. So would you agree that we want to divide? Yeah. So we're going to divide this value into 28,560 and get an answer. But I want to try to get the unrounded answer. So I know this will give me my value of P, but I want to show you the calculator. Okay, so from the previous screen we know how we're going to simplify this. What we did was we took the 1 plus 0.031 divided by 12 to the 12 times 5 power. And then we hit enter. That's that value that I had to truncate and leave off the rest of the decimals. But from our work, we know we're going to take this and divide it into 28,560. So I'm going to do that, but instead of retyping this number, if I look right here, you see it says answer. So what I'm going to do is hit second and then the answer key. And it's going to divide 28,560 by that without any kind of rounding error. So the answer would be $24,464.11. Okay, so what if your interest is not compounded 12 times a year or 365 days a year? What if it's continuously compounded? Well, we need a new formula, but we've seen E before now. So E is just what we're going to use anytime it says compounded continuously. So we call this the PERT formula. B of t equals P. P is still your initial money amount. And PE to the RT, R is still your interest rate, and you still need to divide by 100 when you put it in here. And T is still your time in years. So B of t equals PE to the RT. You only use this formula here when the problem says that your interest is being compounded continuously. It's called PERT. Okay, so here's the example. It says continuous compounding. The problem says $1,500 is deposited in an account earning 2.9% interest, APR, compounded continuously. So right there, that tells me that I need to use the PE to the RT formula. And we know the initial balance is $1,500. E is a natural number E, it's not a variable, and we've talked about where to find that on the calculator. E to the 2.97 divided by 100 is 0.0297 T. So that's the answer to A. And then B, to find the value after 20 years, that's B of 20 equals 1,500 E to the 0.0297 times 20. And if we have an input-output question, we can just type that in. Your E button is to the left of 4. You have to hit second and the LN key. And you should get 27.1683 cents. Okay, so the last question, part C, says, how long will it take for the original balance to double? So if the original balance was $1,500, then we're going to want our ending balance to be $3,000. So if we put $3,000 in to our ending balance and $1,500 in to our initial balance, then if we use our little trick before about dividing out the initial value, you're going to notice something here. 3,000 divided by 1,500 is 2. And so I really don't need to tell you an initial balance. If I asked a question like, how long is it going to take your money to double if you earn 2.9% APR compounded continuously, it doesn't matter what the money is. You'll divide it out and get a 2 anyway. So this works for any amount of money. At this interest rate, this time is what it will take for your money to double, whether you've invested $1,500 or $1 million. Okay, so we know we're going to use the calculator to do this, so I'm going to pause now. Okay, so we got T is equal to 23.34 years. And again, that's how long it would take you to double your money if you invested $1 million or $45,000. It doesn't matter. How long it takes for your money to double question, if you divide out the initial value, you'll always get 2. So something to keep in mind. Okay, so if I put 2 in first this time, and then I'm going to need to use the E button, which is right here. So I'm going to hit second, E to the X, so there's my E to the 0.0297 X. And then if I hit zoom 6, that's my Y equals 2. Here comes my exponential function, and I'm waiting for it to intersect, and it clearly does not intersect here. So it does not intersect. So I'm going to need to go to the window and make that 100 years. I'm sure that's enough time. And now try it again. There's my Y equals 2. Here comes my exponential function. Clearly see an intersection, so we'll do second calc 5, enter, enter, enter. And it's going to take 23.34 years for your money to double. Okay, so this one says, what lump sum do parents need to deposit in an account earning 9% compounded continuously so that it will grow to $40,000 for their daughter's college tuition in 18 years. So it's compounded continuously. So the balance after T years equals PE to the RT is what we need to use. And this time we have an ending balance of $40,000, but we don't know the beginning balance. And we know our R is 0.09, and we know our T is 18 years. So this is an algebraic problem where we can solve, we don't need graphing, we can solve for P by dividing out this value here. Okay, so I'm going to put this in the calculator. E to the 0.09 times 18 power is a very long decimal. So we'll have $40,000 is equal to P times 5.053 090317, and it probably keeps on going past that, but we want to use the calculator's answer button to not have a rounding error. But I wrote this down so that I can see that the next step would be to divide that value into 40,000. And so I'm going to get an answer, but I have to use the calculator storage answer key. So if you type in 40,000 divided by, and then hit second answer, it'll take that unrounded 5.053 value and use it, and so you get an exact answer of $7,915.95, and that's doable. That's a good interest rate. Okay, so this one is comparing compounding options. Suppose you want to invest $1,000 and there are 3 investment options. One would be 10% compounded annually. The second would be 9.8% compounded quarterly, and the third one would be 9.7% compounded continuously. Which investment is best? So you may want to try this, pause me and try this on your own, but what we're going to do is use the 1 plus R over N formula for the first two and the PERT formula for the last one. Investment C, even though it has the smaller interest rate. Okay, so what I've gone ahead and done here is I've put the equations in my y equals, because this is a case where we want to compare several years, and so if we put all 3 equations in, we can use the table capabilities to compare. So I've already put the equations in, and what I can do is go to second window or second table set and just start at 1 year and count by ones. And then if I go to the table, you can see after 1 year, my first equation is going to give me $1,100. My second equation is going to give me $1,101.7. And my third equation, the compounded continuous equation, is going to give me $1,101.9. So you can tell after 1 year that the investment that is best is investment C. But we can also compare, after 10 years what the difference is. And so here you can see A would give you $25.93, B would give you $26.33.2, and C would give you $26.37.9. So even though you have a smaller interest rate, because it's continuously compounded, you're $4 better than with Y2. And if you keep comparing, maybe another point to compare would be after 25 years. After 25 years, Y1 at 10%, equation 1 at 10% gives you $10,835. That's your value after 25 years for equation 2. And after 25 years, the continuously compounded interest gives you a balance of $11,302. So investment C, clearly best. Okay, so we're done. The learning objectives given a savings account scenario. Use the annual percentage rate, compounding period, and the initial principal to determine the compound interest model. Use that model to calculate how much money will be in the bank at a future point. That's an input-output question. And then use the model to solve for the length of time needed to reach a given level. That's an output-input question. And then we even did some more different kind of critical thinking problems. And remember, there are two types of formulas. There's the PERT formula for continuous compounded interest, and then there's the 1 plus r over n to the nt formula for different types of compounding periods. So what we will do in class the next time we see each other is the lab manual, and you can work on the WebAssign right now if you'd like.